Assalamu alaikum, ma'am.
Assalamualaikum students, how are you?
Assalamualaikum, ma'am.
You're very good. I wish you had a very great exam for grade 9 and I hope you will get a very good marks and hope for the very best. So welcome all in grade 10. First of all, mark your attendance in the chat box.
Ma'am, I can't hear you.
You can hear now?
जी मैम अब आ रही है.
Yes.
Okay. So girls, all of you welcome in grade 10th and I hope you have buy your physics book and notebook as well, right? So if you first of all girls, mark your attendance in a chat box, okay? So if you open your book, if you see the page of contents, you have seen there are unit 10 to unit 18, right? So again in grade 10 you have total 9 chapters. So during online lectures we will take start from unit 11, that is a sound, okay? All of you have books with you? So the contents of this lectures include sounds, in which we will discuss what is sound, what is the definition of sound, then production of sound waves, that how sound waves they are produced, right? Then sound requires medium for its propagation. Obviously, when sound travels, when it's propagate, it will require any medium. So we will discuss these mediums by which the sound can propagate or travel, right? And the last content that will be covered in this lecture is a longitudinal nature of sound waves. And sound waves, they travel, they have a longitudinal wave nature, right? So all these 4 contents, they will be discussed and explained in detail in this lecture, right? Then the learning outcomes of this lecture includes, you will be able to explain how sound is produced by vibrating sources. When you are able to know that what is sound, then you must know that what is the purpose of vibrating sources. Then sound waves require a material medium for their propagation, and then also you will be able to describe the longitudinal nature of sound waves as a series of compression and rarefaction. Now we will take start from our lecture. You can also open your book and on page now first of all we will discuss what is sound. So it's very common when you see a different example of sounds in our daily life. As I'm talking, you can hear me clearly. It's also an example of a sound, right? When you close the door, you hear some sound. This is another example of a sound. If you see a lion roar, you can again observe that this is some sound, right? So there are different examples of sound that we observe in our daily life. So the first question is that what is sound? How sound is produced? When two objects they vibrate, sound will be produced. So because of vibration, the sound will be produced. If you remember unit 2, in which we discussed the vibratory of motion. So what is vibratory motion? Can you tell me? Yes, girls? Yes, Zainab? Can you tell me what is
To and fro motion of a body.
Okay, very good. To and fro or back and forth motion of a body is known as a vibratory motion. So it's same like a vibration. When two objects they just have to they to and fro or they just move back and forth, they will produce a vibration. So when the objects they vibrate, and this vibration they travel in the form of a wave, and that wave is a sound wave. So in this way, a sound wave is produced. So sound is form of energy that travels in the form of waves from one place to another. So there are 2 important points regarding sound. One, you must know that what is motion and what is a wave, right? So these 2 points give you a definition of a sound, right? So if you see a figure 11.1, there is a guitar, and if you just vibrate the string of these guitars, that means if you just vibrate the string, the 2 strings they will be come in contact with each other and they will produce a vibratory motions and vibrations will be occur. So these vibrations, they will be travel in the form of some waves, and these waves are a sound wave that reaches to our ear. So in this way the sound is produced, right? So this is the definition of sound, that sound can be produced by vibrating a by vibrating body, and these vibration must be traveled in the form of a wave to our ears. Then we called it a sound. So our voice result from the vibration of our vocal cords. So when our vocal cords they vibrate, they will produce a sound.
Ma'am, I can't hear you.
Our voice result from the vibration of our vocal cords. So when our vocal cords they vibrates, they will produce a sound. Human ears and the vibration, human heart and the vibration of other organs like lungs also produce sound waves. Doctor use stethoscopes to hear the sound. All of you are familiar with the instrument that is stethoscope, and whenever we went to the doctor, go to the doctor, and he check our heart rates, he used the instrument that is known as a stethoscope. So what is the purpose of stethoscope? When the diaphragm, they are basically the diaphragm that is a plastic part that is placed on the chest of a patient, and it will detect the vibrations of a heartbeat or check the heart rate, right? So these vibrations or heart rate can be passed through the hollow tubes that are placed in the doctor ears. So with the help of these hollow tubes we hear the sounds of a heart vibration that can be heard by the doctor, right? So in this way we hear the sound, right? So this is another example of a sound that can be produced by using stethoscope, right? So do you have any confusion in this slide? Okay, so for your information, stethoscopes operates on the transmission of sounds from the chest piece. So basically this is the diaphragm. When this diaphragm is placed on the chest piece via air-filled hollow tubes, and these two are the hollow tubes that are placed in the doctor ear. See, if you can see, these are the two hollow tubes, so to the listener ear. The chest piece usually consists of a plastic disc called diaphragm. So this is the diaphragm, and when with this diaphragm is placed over here, the heart rate, sound of heart vibrate, and these vibrations they travel in the form of wave to the these hollow tubes to the ear of the listener or a doctor, right? If the diaphragm is placed on the patient's body, sounds vibrates the diaphragm, creating acoustic pressure wave, which after multiple reflections travels up the tubing to the doctor ear. So girls, here what is the acoustic 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 pressure waves? Acoustic pressure waves are basically the sound pressure waves. Okay, so this is a very common example of a sound, and here the medium of us, if you see in the next slide we will learn about different mediums of sound. Here the medium of a sound is a solid, because these hollow tubes they are made from solid, right? In first two slides we will discuss about that what is sound. So, and the two examples of sound, one is guitar and other is a stethoscope. Right now we will see that sound is produced by a vibrating body. When we will discuss when we discuss the definition of sound, we see that the sounds are produced by a vibrating body. By the help of this activity 11.1 we will clear that sounds are really produced by a vibrating body. In school laboratories, we use a device called turning fork to produce a particular sound. So if you see figure 11.2, there is a turning fork. This is a turning fork. If you see, it's straight from the down and it's U shape from the upward. This U shape, basically these are known as the prongs of a turning fork. This is the one prong of the turning fork and this is the other prong of a turning fork, and it is very commonly used to observe to see the vibrations that are produced from the sound, right? So if we strike the turning fork against a rubber hammer, the turning fork will begin to vibrate. Let's see if we have any a rubber hammer that is shown in this figure. It's made from a pink color. If we just strike this rubber hammer to this turning fork, what will happen? These prongs of the turning fork, they will be start vibrating. If let's say this is the original position, it will be moved to and then it will move fro to fro. So the motion is to fro and vibrations will be produced. So when you observe it very clearly and see it very closely, you will see the vibrations that are produced by this turning fork. And if you bring this turning these two prongs to close to your ear, you will listen a sound, right? We can hear the sound produced by turning fork by bringing it near our ear. We can also feel the vibrations by slightly touching one of the prongs of the vibrating turning fork with a plastic belt suspended from a thread, figure 11.3. Now if you see a figure 11.3, there is a one thread is tied from this support and there is a one ball that is tied with the help of a thread, right? So if you just place a turning fork like this and you just move this ball here and then just release it, what will be happen? This ball will strike these prongs and they will be start vibrating, and then when they will be vibrating, obviously they will produce a sound. So we can, again with the example that is mentioned in figure 11.3, we can say that sound produced by a vibrating body. Touch the ball gently with a prong of vibrating turning fork. The turning fork will push the ball because of its vibration. Now, if we dip the vibrating turning fork into a glass of water, we see a splash. As you observe that when you just release this ball, this turning fork is start vibrating. And if you take a glass of one glass that is filled with a water and you just invert this turning fork in this glass of water, what will be happen? The waves will be seen very clearly that is produced on the vibration of a prong of turning fork, right? So what does make the water splash? Obviously, the movement of a prong and its vibration make the water to splash. From this activity, we can conclude that sound is produced by vibrating bodies. So girls, do you have any problem till here? If you have, you can ask me now, okay? So this is a real example. If you just fill a water in a glass and you just bring these two prongs that are vibrating into the glass, you will see the waves they are generating like this. See? So this is a real life example. Uh, Now we have discussed that how sound is um, produced, right? They are produced by mean of vibrations and a wave, right? Now the next topic is sound requires material medium for its propagation. Can anybody tell me what is a medium? Yes, girls, do you know what is a medium? Yes,
A
Kashav.
source of transporting something.
Okay, so can you give me an example of medium? Yes, Kashav. Medium can be solid, it can be liquid, or it can be a gas. We have learned three mediums, right? So sound required material medium for its propagation. So in this lecture, we will see that how sound travel, it must be need some medium for its propagation. Propagation mean traveling. So If there is no medium at all, sound cannot be propagate, sound cannot be travel. So medium must be a necessary for a sound to propagate, right? And we have three different mediums. One is solid, other is liquid, and there is a vacuum pump. On the vacuum pump, a bell jar operators is placed. In bell jar operators, there is an electric bulb that is placed fixed inside this bell jar, and these there is some kind of wiring, and these two wires, they are connected to the power supply. It will be start coming out when we will pump this vacuum pump, right? So as the air is draining out from this bell jar, what will happen for its propagation is gas, that is air. It is a mixture of gases, right? So in the presence of air, we can hear the sound because this medium is basically travel the sound to our ears. When we remove all the air, we cannot hear any sound, right? So the medium is very important for the propagation of sound. So it doesn't necessarily that sound can travel through anything. Sound needs some medium for its propagation. Sound cannot travel through a vacuum. Can you tell me what is a vacuum? Yes, Adisa. Can you tell me what is vacuum? Yes, Zainab. Yes, Zainab Siddiqui, what is vacuum? Yes, girls, hurry up.
Ma'am,
Yes.
a vacuum is something that has no air flow.
Yes, vacuum is a place when there is no medium, and when there is no medium or almost it is empty, right? So if we see the example of space, it's a vacuum. There is a no medium. There is nothing present in the space. So vacuum is basically an empty place. So when we vacuum this electric bell, we can hear no sound, all the power button is on. So this is the example of a medium and the medium here is an air. Similarly, if you I tell you a very common example, if you stand on the one side of a brick, right? A brick is made from which medium? It's a solid, right? And you ask your friend to stand on the other side of the brick, and you ask him to say anything, and she say any word, and you will be hear very clearly that word because sound can propagate through solid, right? Similarly, if someone is standing outside the door, you can easily hear the sound if the other person is speaking. Again, here the material medium is a solid, so it's mean sound can also travel through solid. Similarly, if you are at your home and just the bell is ring on the door, and you hear the uh, sound of a bell. So how the sound of a bell travel to your ear? It travel through the medium that is known as air. So here the material medium is a
Yes.
gas, right? Very good. So similarly, sound can also travel through liquid. For example, if you just take any beaker, and that beaker is filled with a water, right? And if you take any you can take any bell, and this bell does not touch the surface of a liquid, and you just strike it, you will hear the sound of a bell, because here the medium of a bell is a water. Similarly, if you see that the boat they are traveling in the water, you will hear their sound because the medium is a water, right? So these three, by the help of these three mediums, the sound can propagate, it can travel, right? Okay. uh, Now we will see the nature of a sound wave, that how sound wave travels. First of all, we will see that what is a longitudinal wave is a wave. Let's see, in this case, if there is a, let's see, the sound wave is traveling in this wave, right? And there is a medium. Let's say this is a mic and someone is speaking from this mic, then the sound wave is traveling like this, let's suppose, right? when the sound wave is traveling, obviously here, what is the medium? The medium is a air, right? The medium is a air. The particles, their line over here. The direction of particles can be like this, like it can be parallel to the sound wave, or it can be let's say this is a mic and someone is speaking from this mic, and the sound is traveling. So the sound is traveling towards the right, and here the medium is a gas, right, air. So the particles can be moved in this direction, or they can be moved anti-parallel to the sound waves. These are the longitudinal waves, right? Longitudinal, you can say, you can remember with the help of a word line, right? The direction of sound wave and the direction of particles of medium can be same, but it can be parallel or anti-parallel. You can it can be very helpful to understand by the help of example that is given in figure 11.6. Let's say this is a turning fork. This point is O, mean this turning fork is at rest position, right? This is position A, this is position O, and this is position B. Now as it is the rest, and here the medium is, if the sound is produced, the medium should be air, and the particles of a gas, they are aligned like this, means they are moving very uniformly, right? There is no disturbance. But what will happen if you just uh, s- um, move this prong B towards the right? What will happen? All the particles, they will be come in contact with each other, like the pressure will be increased when you just push this prong B on towards the right. When, so you can see that here the pressure will be increased. So the pressure here is basically a sound pressure, and this pressure is known as a compression, right? When the density of sound pressure is high, you see that the prong is moved towards the right, and all the particles, they will be merged together. So here the pressure will be pressure of sound is greater. So when the pressure of sound is greater, compression will be occur. The rest is a rarefaction, where the density of sound pressure is low, right? So after some time, it will be go back to its original position O, and then towards position A. Then what will happen? This pressure will be moved on the other side, and again here the density will be less. So here again the pressure will be less. So here the compression rarefaction will be occur, and compression will be transferred on the other side. So in this way the sound waves travels. One if one is compression, other is rarefaction. If one is rarefaction, other is compression, rarefaction, then compression, right? So girls, if you have any problem because it's a bit tricky, you can ask me now, okay? If there's any confusion in this topic. Yes, girls, it is clear.
Ma'am, is the vibration just moving along, or when we change the shape, then it does?
See, when you what is vibration? It's a to and fro motion. So when you will move this prong towards P, what will happen? All the pressure will be exert on this place, right? So all the particles, they will be combined together. They will be create a pressure. When they will be create a pressure here, the pressure will be maximum. So you can name it a compression. When this prong B will be moved towards point A, what will be happen? The density, the particles will be start aligning again, and at and one point come, they will be again like the previous one. And there is a, and here the density of sound is a low. So when the density is low, the refraction is occur. Okay. Now it can also be clear with this example. And see, this is a turning fork, and when you just move it one, and it will be start vibrating. Illustration of longitudinal wave formed by vibrating turning fork in the air. Compressions are places where air pressure is slightly higher than the surrounding air pressure due to high density of air particles. Obviously, where the when you move this, the particles will be come close together and their pressure will be increased. And when their pressure will be increased, obviously this is a sound pressure, then compression will be occur. So this blue color show the compressions, right? While refractions are the region correspond to low air pressure due to low density of air particles. So this white line is the region of compression. Here the density of the particle will be low. When it will be this prong will come back, it will transfer the pressure on the other side. So here again the pressure will be increased, then this pressure will be transferred on the other side, and here the density again will be low, or it's a region of a rarefaction. So it's from a uniform pattern, compression, rarefaction, then compression, rarefaction, compression, rarefaction, and in this way the longitudinal waves are produced in a in case of a sound, right? Now if you see the quick quiz that is given in your book as well, right? If you open page number 22. Identify which part of these musical instruments vibrate to produce sound. So first one is a electric bell. So here's a hammer and here is a soft iron amateur. When hammer and this soft iron, they will be vibrate with each other, then electric bell will produce a sound, right? Part B is loudspeaker. So this is the loudspeaker. When the diaphragm of this loudspeaker will start vibrating, the sound will be produced. Then part C is piano. When the string of these piano, they will be vibrate with each other, they will come in contact with each other, the sound will be produced in this instrument. Then if you see the part D is violin. When this violin when these strings of violin, they will be vibrate with each other, again the sound will be produced. And part E is fluid. When you just this is when you just blow the air to this point from your mouth, the air come out, you will suck the air towards your mouth, and here the atmospheric pressure will be generated. So because of this air pressure, the flute will be vibrate. So here the vibration will be occur with the help of a air particles, because air particles will be in contact to your mouth, right? So the so with the help of these you can see that these parts, the musical instrument vibrates to produce sound. So girls, if you have, this is a lecture for today, if you have any confusion regarding this lecture, you can ask me now, otherwise I have to end the meeting. Yes girls, do you have any confusion? No confusion? Okay, thank you so much. Get ready.
Excuse me, ma'am.
Yes.
मैम मैंने आपसे पूछना था कि जहाँ पे एयर डेंसिटी कम होगी वहाँ पे साउंड वाइब्रेशन भी कम होगी, तो एयर डेंसिटी मतलब किस एरिया में कम होती है?
जहाँ पे आपके पास पार्टिकल्स होते हैं वो कम हो जाते हैं. जैसे prongs को when we'll move toward the right, what will happen? The particles, they are aligned together. When you move the prong, what will happen? The particles will become close together. When they will come close together, the density will be higher. When it will be when the prong go back to its original position, what will be happen? The density will be again minimum. Okay.
Okay, ma'am. Thank you.
Okay, thank you. Okay, class, Allah Hafiz. Get ready after 10 minutes. Okay. Allah Hafiz.